In this class we're going to talk about statistics. Now I appreciate that this may strike fear into the hearts of many, but in fact it's quite a straightforward class, and the topic of statistics itself, A, it's very important, and B, it's not so difficult. So let's look at some ideas about statistics which will help to introduce the subject. First of all, look at the word statistics. You'll notice it's a plural, statistics. It's got an S at the end. And this normally means a set of data. For example, production statistics. Now, statisticians, when they refer to a whole set of data, they talk about the statistics. The statistics suggest something. So that's one use of the word. It's a plural noun. Secondly, statistics is, or it refers to, statistical methods. These are ways of abbreviating and classifying numerical statements so that they become clear, understandable to us. In other words, the data has been refined into something we call information. Information is useful. Information is what we're looking for. Decision makers need information to make good decisions. And how we get good information is by refining data. So, crude data is what is collected, and then it's refined using statistical methods so we can understand it and make decisions based upon it, and that becomes information. So a big distinction between information and data. Now let's look at statistical data. Generally speaking, we're dealing with numerical data. I say generally speaking because it is possible to assess people's attitudes towards particular events or particular institutions, or ask people their attitude about government policy in some respect, and classify it numerically and analyze it. It's a big topic and it's full of issues and problems, and it's not to be dealt with in this class, but I'm just saying it can be done, and it is done on a very regular basis. So for example, we could assess the health of people according to the number of days they're away from work. That's a very crude statistic, but it may be possible. Of course, we'd have to have some benchmark. We'd have to say, well, healthy people only have so many days off work. Unhealthy people have more days off work. It's very crude, but it may be possible. But statistical data enables us to make some sort of decision, albeit good or bad. And as I said earlier, we can assess sometimes situations which are not normally amenable to numerical analysis. So we could ask, what is the brightest light bulb? What, in your opinion, is the brightest light bulb here? And the brightest one gets 1, the next brightest gets 2, the third brightest gets 3, and we can work out which bulb is the brightest in the opinions of the people making the decision, making the assessment. So it is possible, but as I said earlier, full of issues and problems. Business people need statistics to make good decisions. They need good information, and information comes from the data, which is refined through statistical techniques. So business people need to know what the changes in the markets are. So they often have the situation where production takes place well in advance of sales. Well, they need to know what's likely to happen in the market in 6 months' time, or whenever. They can't just risk a lot of resources and it turns out later on that they had misread the market. It happens, but they try to minimize that possibility. Of course, statistical problems must be clearly stated, and we need to know what's included in surveys. So this introduces us to two concepts here, which is not on the slide. One is this idea of a survey, and the second one is the idea of a population. So what is it we're going to survey? What are we going to check? Well, let's say we're going to check on the table. It says a survey into industrial pay, presumably in some country at some point in time. So it's a survey into industrial pay. So we're going to look at workers in industry, sort of engineering type industry. Now that becomes our population. We're not interested in the service sector, we're not interested in police or musicians or librarians or the armed forces or entertainers or whatever. We're not interested in these people. These are a different sector, they're a different classification. We're interested in industrial. That's our population. Now, if that is the case, then should we now check all employees? Well, it's going to be very expensive. There might be millions of them. So we can't waste resources or use resources to check all of them. And by the time you've done it, it probably has all changed anyway. So what type of occupation should we select? What type is representative of the population? If we're going to select only a sample, only a few, and hopefully that few is representative of the whole population, what type? What type of occupation? Occupations vary widely. Some are highly paid, some are not so highly paid. Male and female. We know that for the same job, everyone should get the same money. I mean, that's fairness, male or female. But it may not be the case. Overtime working. If there's a lot of overtime working, then salaries will look higher. Bonus payments are the same. Or it might be the case that people get paid in kind. Partly in kind. Farmers eat their own produce. If you've got a garage, you'll fix your own car. You use the resources of the garage, but you fixed your own car. So we need to have a very clear understanding of what it is we're investigating. It has to be very precise. One way to do this is have what's known as a pilot survey. A pilot survey is simply a survey that's put up in before the main survey, just to see what issues come up, what problems are involved in conducting the survey, what issues. And the pilot survey normally throws these out, so they can be corrected before the main one is conducted. Now, the sample selection. Well, the idea here is we can't do the whole population because it may be too expensive, or it may not be possible to do the whole population. So what we do is we take a sample, we take a small number and hope that that number is representative of the population. So if you work out the average for the small number, the population, we hope, will have the same average. All of this really hinges on, put the cursor onto the screen here, the size of the sample and also how the sample was selected. Well, the size of the sample, the bigger the sample, the more we'd expect it to correspond to the population. However, the bigger the sample, the more expensive it is. And how it was selected, well, we can't just select it on the basis of convenience, because that is biased. If you're conducting a survey into ice cream, and you just ask your friends what they think of ice cream, that's biased. Your friends may not be representative of the whole population. So their attitude towards ice cream may be different to that of the population. So, issues. Let's take an example. Let's say light bulbs. This one is very famous in statistics. Let's say we have 1,000 light bulbs and we want to find out how long they will last, how long the life of a light bulb is. Well, if you're the producer, you could test all of them. That would be silly because you'd have nothing to sell at the end. You've tested all of them to destruction. So you've got nothing left. So what you would do if you were the producer is you'd pick a sample. Now the size of the sample will be worked out by statisticians, but let's just say here, to keep it simple, let's say it's 40. You'd pick out 40 randomly. You'd pick them out without any prejudice, without any predilection for a certain light bulb, without sort of picking a light bulb because you like the light bulb. You just pick them randomly. Pick them over a day, perhaps, or pick them in some way where it's fairly random. Getting a random sample is very difficult, and that's a subject of a different class, and we looked at later. But for the moment, just take my word for it. Getting a random sample is not easy. But let's say you pick 40 and you test them. Now, hopefully, once you've worked out the average life of the 40 bulbs, each of them, that will give you an indication for the full 1,000 light bulbs. Of course, it depends on how confident you are. What you will say is the average light bulb lasts a certain period of time, plus or minus so many hours, because it's unlikely that the full population will have exactly the same average as the sample. Now, data collection. Well, there are two types of data. There's primary data and there's secondary. Primary data is going right to the source of the information, collecting it firsthand. Going right to the source. So primary data is conducting a survey. Primary data is collecting the figures right at the source. Secondary data, by contrast, is using published data, data that has been collected previously. So the government, for example, collects a lot of statistics, and we may access those numbers and do our own analysis. The data has to be organized when it's done. It has to be coded, ready for analysis. So it has to be clear. The coding has to be clear to enable the analysis to take place. And once that happens, you apply a particular analytical technique, statistical analytical technique, to the data, and the results come out, and you interpret the results to try to explain the results. Are they good, bad? Do they accept or reject the situation? What do the results tell us? Then, of course, it's presented. It could be charts and tables or whatever. And generally speaking, there's some sort of report associated telling the ups and the downsides of the procedures and the limitations of the study itself. What are the criticisms of the study? So that anyone using the results will be aware that there may be issues. It may not be 100% accurate. Management uses statistics for all sorts of reasons. To make good decisions, I suppose, is the essential one. But statistical techniques are very important in helping make good decisions. It converts, as I said at the outset, it converts data into information. So it helps the decision-making process. And the areas in which it helps most specifically, and I'll just put the cursor onto the screen, are this stock control, market research, quality control, and sales trends. So we'll have a look at these few over the next slides, a few slides, and see what they've got to say. First of all, stock control. Well, stock equals resources, and if there are too much stock in the company, then resources are tied up unnecessarily, resources that could be used for something else. It's what an economist would call an opportunity cost. The cost of holding the stock when that resource could be used for the next best alternative, could be used for something else. So holding too much stock is wasteful. On the other hand, holding too little stock might be dangerous. Production may stop because there's not enough stock, or customers may become frustrated by the fact that lead times have been extended because they can't get their goods because production didn't take place. So having too little stock is bad, having too much is bad. So there is an ideal, and statisticians can help in working that out. So information, statistical information, numerical information, is used to try and work out what is the ideal amount of stock. And allowing for risk and uncertainty and the costs of holding the stock and so on, a figure can be worked out which is reasonable. Market research is essential. Trying to find out what's happening in the market is surely one of the most important activities that marketing people can engage in, trying to find out what are the trends in the market, what are customers, what do they want, what are they doing. That's essential. And if that can be assessed quantitatively, that is good. Quality control. Well, we're back to light bulbs in a sense. We want to know what is the quality of the item. And to do that, sampling within the production has to take place to find out what the quality is, if it meets standards and so on. And the example with the light bulb, here it is again, I just mentioned. We have 40 light bulbs. We take 40 out of every 1,000 to test for the life expectancy. And let's say we found it was 500 hours on average. Does this mean that the sample has got, each of the sample has got an average of 500 hours? Does that mean that 1,000 light bulbs would have the same? Well, not really. It might be different. It depends. It depends on the size of the sample, and it depends on how the sample was selected. But it might vary. So we have, I'll put the cursor onto the screen here, we might have this idea of the degree of confidence. The degree of confidence in the result. So what statisticians would say is that the 1,000 bulbs, they've got 500 hours expectancy plus or minus a certain number, and they say, well, we are 95% confident or 99% confident that that is right. So it'll be between, let's say, 480 and 520, and we're 99%. All the light bulbs in the 1,000 will be within that. They're not saying 100, they're saying 99 or 95 or whatever it is. So it's a probability figure. And we call that the degree of confidence. Sales trends. Well, management need to have some idea about sales trends if they're to make informed decisions. And planning must be based on something. It must be based on information. And information comes to us from statistical analysis, from what we know about the world and the market and the customers and the production facilities and so on and so on. And it is, if it can be quantified and measured, then it can be analyzed and decisions can be based upon it. It doesn't mean necessarily that all decisions are good. The information itself may be bad because the data may have been badly collected, the sample was wrong or was biased or whatever. But subject to all of that, the principle is if the information is good, the decision will be made. So that's an introduction to some of the ideas in statistics. It's an important area and it's well worth not fighting it, certainly, just coming to terms with a lot of the ideas in this class, because most statistics from here on will be taking the topics that I've mentioned briefly, very, very briefly in this class, and amplifying them into much bigger topics and much more sophisticated topics. But that's a brief introduction. Hope you found it useful. So thank you for watching.